Good day, grade 12 learners. Welcome to today's technical mathematics lesson. My name is Moses Maudu. This lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. So today we'll be looking at trigonometry, part 2. Just to quickly go through the lesson objectives. After this lesson, after the end of this lesson, we must be able to do the following. We need to be able to solve the two-dimensional problems by using the trig ratios, and those that are the ones that involve the right-angled triangles that are done in grade 10. We also need to know how to solve problems in 3 dimensions that are done in grade 12. We need to do the measurements must always be given for the angles, lengths, and sides. So in other words, you'll always receive a question whereby all the sides are given. The sides are given, some of the sides are given, some of the angles are given. And those will be the measurements. We must also be able to draw the sketches of the following. The graph of y equals to a sine x plus q. So the graph can be given in that form. We must be able to draw the graph of y equals to a cos x plus q. The graph of y equals to a tan x. So in other words, I can be given the value of a there. The next graph is the y equals to sine of ax. So for instance, the sine of 2x. The other one is y equals to the cos of ax. So which means that you won't be given a graph whereby it say y equals to tan of ax. So only the tan, the a will be as an amplitude there. Now we must also be able to draw the function, this function also, defined by this. So where we have the movement of p plus p, and that p will denote an angle. So you can see that is inside the bracket, so it must be x plus p. The x is an angle, the p will be angle. So these are the graphs that we must be able to do. You are not going to be given a graph where you have y equals to tan of x plus p. So those graphs will not be given to you. So these are the only graphs that you need to practice, and we need to understand how to draw them. We also need to understand how to interpret when the graphs are drawn. So there will be questions that we're going to be doing on that. Just some pre-knowledge on the work that we're going to be doing. The ratios, we must always know these ratios. You must always know your saw, which is your sine, its opposite over hypotenuse. Right? In this case, if I'm looking at the diagram, it is the BC side over the AB side. So that is the sine. So if I need the cos, it will be the adjacent side over the hypotenuse. So which is A over that H, which is represented by the AH there. The tor there represent the tan, which is opposite over the adjacent. Opposite over the adjacent. So if my angle is there, my opposite side is that side, and my adjacent then is this one. So adjacent next to. This angle here is next to that line. So that will be an adjacent side. Okay. Now let's quickly go to the grade 10 work that you need to understand before we go to the grade 12 one. So if you look at the angles of elevation and the depression. So what is that angle of elevation? Elevate up. Okay, depression down. Well, you know when you are depressed, down. Elevate up. So in other words, if I have an angle of elevation, so I look at that angle from the observer side, I look up at that object there. So I'm looking up. So if I'm looking up, the angle that is formed between the horizontal line and my line of sight, it's called the angle of elevation. So this is the angle that we are going to be talking about most of the time when you're doing this 2D and the 3D. So the object is there, angle of elevation is there. So this is my observer, the observer side. So in other words, the line of sight is that one. Remember what is an angle? It is an amount of space formed between two lines. So this amount of space here is an angle and is measured in degrees. And obviously in technical maths, you know you can also measure it in radians. So the amount of space between the horizontal line and the line of sight, that amount of space, that whole space there is an angle. So that's why we call it, and in this case we call it the angle of elevation. So what will be the angle of depression? So obviously in angle of elevation, if I'm standing like this and I'm looking at the tree, the top of the tree, so my eyes will go up to check the top of the tree. So if I'm standing here and from there there's something floating down there, the river, how do I look at it? I look it down. So if I look at that object down there, then the angle that is formed between my observation line, which is the horizontal in this case, and my line of sight, so that object, that angle that is formed there will be the angle of depression. Because I'm looking my angle, it's formed between the horizontal and that line of sight which is down there. So I'm looking at an object which is down there. So obviously if I'm standing on top of the mountain and I'm looking at an object down there, the angle that is going to be formed there will be the angle of depression. And this you have done in grade 10. Now let's look at a practical example here. Here's this guy, he's standing there on top of there. Now it's Chris is observing an object in the sea below him. You see, it's below him. So what type of an angle that is going to be formed there? That is the angle that is going to be formed there. So it is the angle of depression. Because my horizontal is there. This is the line of sight. So I'm looking at that object there. And then my line of sight and my horizontal will form an angle of depression. So now, from a point 2 meters above a 14-meter cliff, very important to understand that statement. Because what does it mean? It means that he's on top of the cliff, his horizontal is there, and they say it's 2 meters above. So which means that Chris is 2 meters tall, right? So the cliff there, it's 14 meters. So in other words, that cliff there, it's 14 meters. Which means that this line here is going to be 16 meters. Very important to understand this, because the statement that is written there, we need to take those values and put them on the sketch so that we can make sense of that sketch. Now it says he has been told that the perpendicular distance, obviously if he's standing there, that cliff there, it's perpendicular to that. This is what they're saying now. The perpendicular distance from the floating object to the base of the cliff. So in other words, this is the object, that is the base of the cliff, and they say the distance there, the perpendicular distance there will be 18 meters. All right. So now they want us to calculate the angle of depression in degrees. You see, in degrees from Chris to the floating object. So we want to calculate that angle from the observation point, of which the horizontal will be this one, to the line of sight, to the object, to the floating object. So now I can see this line here will be 18 meters. This line here will be the same as that line there. So that will be 16 meters. So now I have my 16, I have my 18. How did I get the 16? The cliff is 14 meters tall. Chris is 2 meters tall. That whole line there is 16 meters, which will be the same as that one. Remember, so that also that line is perpendicular to this one, so therefore that line is 18, therefore that one will be 18. Now I have all this information. I'm going to erase that information. I don't need that one because I already have a right angled triangle. Can you see? I already have a right angle triangle here, and in a right angle triangle, which ratios do we use? Sine, cos, and tangent. But now, look at what is given. If I'm standing here, that's the angle of depression. I'm just going to call this angle theta, or angle A. Right, angle A. If I'm standing there, and I've got that side here, that side there is going to be my opposite. And this side here is going to be my adjacent. Which ratio uses opposite and adjacent? Tan. You got it right. So it's tan, so I'm going to use the tangent, right? So it will be the tangent of an angle which is equals to. Remember that whole side there, it's 2 plus 14, which is the same as that one. So it will be 16. So it will be my opposite will be 16. And my adjacent will be 18. Then I'm looking for the angle. So the angle that is going to be formed there will be A is equals to. Obviously, I take my calculator and I say shift tan, open bracket, fraction button, 16 over 18, close bracket, equals to. So shift tan, because I need an angle, shift tan, open bracket, 16 over 18 with the fraction button, close the bracket. What will be your angle there? So I hope we will get the same angle, which is 41.63 degrees. They said give your solution to 2 decimal places. Please read the instruction. And the answer is 41.63 degrees. Okay, so this is a grade 10 question. But you need to understand it so that then when you get something like this in the grade 12 paper, you are able to can answer it. Right. The next activity, almost the same question, but in this one we just need now the height. Now, how am I going to get this girl here, this lady that's standing there? She's standing there. Obviously, that should be perpendicular to the ground. Right. Now she's standing there. This is her observation point. So the observation point has got a line here. You see, she's observing from there. Already they say she's standing 50 meters away from the tall tree. So from here to where she's standing, it will be 50 meters. Right? So now, the ground is totally level between her and the tree. So it's totally level. That's why I said it's 90 degrees then. She measures the angle of inclination of the top of the tree to be 24. In other words, she measures this angle from her observation point to be 24 degrees. Right. Okay. You can use a clinometer. You know, the clinometer, we use it for measuring angles. And I think in the pad that you're doing, you're going to be doing something that has to do with the measuring tape. So the clinometer is one of the tools that we use to measure the angles. Okay. Right, so now she's standing there, it's 50 meters, obviously. If this is 50 meters, this line here will be 50 meters. Right, now her eyes, very important there, the eyes is 1.5 above the ground. So in other words, if her eyes are there, they are 1.5 above the ground, which means that from here to there is going to be 1,5, which is the same as that line there, 1,5 meters. So now we have this information. Then we want to find out how tall is the tree. Sure. How tall is that tree? From here to there, how tall will that tree be? But now her observation point is there, so which means that the length of that part of the tree, I know it is 1.5. Oh, no problem. Then we can be able to do it easy. Now we want to check how tall that part will be, the height of that part. For me to get the height of that part, I've got 50 meters, I've got an angle. Which ratio? If that angle is there, that is my opposite. This is my adjacent. Oh, it's nice. We're working with a tan here. So now, now the tangent of 24 degrees. So I'm going to say the tangent of 24 degrees will be equals to, I want to call this one PQR, for instance. Okay. Then I can then say the length of PQ is my opposite. That length of QR will be my adjacent. Right? So now I'm looking for that angle. I'm looking for PQ now. So I'm going to say the tangent of 24 degrees equals to, what is PQ? I don't know. But QR, I know it's 50 meters. So I can just quickly cross multiply this. Then I'll get PQ, it's equals to 50 meters multiplied by tan of 24 degrees. Then I'm going to get the length of PQ. So my length of PQ, if I multiply that, I'll get 22,26 meters. But I am not done. Why? It is because I only have the length of that part here. I do not have the length, the height of the tree. Because the height of the tree starts from here to there. So now, what should I do now? Then I must write down height of the tree will be equals to. So it will be 22.26, which is the length of that, 22.26. Now I must add the 22.26 to 1.5, because then it gives me the height of the whole tree. So the height of the whole tree will now be 23,76 meters. That is the correct answer. So if I leave it here, then I'm going to lose that mark. So make sure that you read the question and you understand the question. It's very, very important, especially with this type of questions whereby you've got a paragraph there, and that paragraph, you must make sense out of that paragraph. And after making sense, take the values to the sketch and make sure you understand. You can draw that sketch nicely there, and then I can just draw the sketch like that, and from there I have this. I know now I have got that, which is my other height here. I've got that, which is my other height. Then from there I've got 90 degrees there, 90 degrees there. I've got 1,5 here. Then I've got 50 meters here, and then I've got 24 degrees there. Then you are able to can see. No, the height that I'm looking for is that whole height. But I can only get it when I know this one, and I add it to that one. Then I get the correct height. Okay. All right. Now let's move to the 2D, 3D now. To the 3D. Now, remember what we were doing? We were working with a right-angled triangle. Now, in the right-angled triangle, it is easy for you to can use the sine, cos, and tangent. But what about when we have a triangle which is not a right-angled triangle? For instance, if I take a triangle like this, any triangle ABC, then I'm given sides. For instance, I'm given this one as 70 degrees. I'm given this as 5 meters. I'm given this one as 3 meters. Now I need to get the other side. Obviously, I cannot use the theorem. I cannot use the three trig ratios. Because why? I do not have a right-angled triangle. I cannot say the tangent of 70 is opposite over adjacent. No. The reason is I do not have a right-angled triangle. So I must come up with a plane. So what will be the plane? The plane is what we are going to be doing now. It's when we have a triangle which is not a right-angled triangle, This is the plan. The plan is to use the rules. There are two rules that I'm going to talk to now, which is the sine rule and the cosine rule. Those are the two rules that I'm going to use in the triangle where we don't have a right angle. So now if I don't have a right angle, I can still use these rules in a right angle triangle, but it will be, you know, a waste of time because I can use the trig ratios. You can still use them, but I don't think it's necessary for you to do that. But in this one, you don't have any choice. You must use the two rules, cosine rule and the sine rule. Now the sine rule states that the sine of A, which is the sine of an angle, over the side. So the side will be the opposite of that angle. So if this is 70, its side will be 5 meters. Now, it's equal to the sine of B, which is an angle, and its opposite over its opposite, which is the B. So the B will be that side. It's equal to the sine of C over C. So if it's C, that will be C. So the sine of A over A and the sine of C over C. But for when I'm working out the sum, I'm only going to use two of this. All right? Or this doesn't matter. Okay? We cannot use all of them at once. We only use two of them. So that I can use sine A over A equals to sine C over C. Sine A over A equals to sine B over B. Sine B over B equals to sine C over C. So I can only use two of them. Right. The cosine rule states that if I need A, for instance, I need a side, I'll have to square the side, and then from there I get B squared plus C squared. Can you see those are the two sides that are not mentioned from here? I've got A, B, and C minus 2 times BC. So the B and the C will be these ones. Cos of A, that angle here must be related to that. Okay, if it's P squared here, it must be cos P. If it's T squared, it must be cos T. Okay. The area rule, we only use it when we are asked. Right. If I'm asked to determine the area of this triangle, I can use that rule here. Okay. Right. For these two rules here, I can determine the sides, I can determine the angles. So I can do that. Remember what is trigonometry? We are actually busy working with the relationship between angles and the sides. So you can see here we've got sine A and side A. Sine B, which is an angle, over B, which is a side. So trigonometry is nothing else but the relationship between the triangles, the sides of a triangle and its angles. So it's just the relationship between the two. So you always see when you say sine of P will be equal to the ratio of the sides. Okay. The sine rule is used when you have a known couple. So when you talk about the known couple, so we're saying this one is a couple because the sine of C over small letter c is given. A side A and an angle A is what we call a known couple. So it is a couple. So if I've got a couple and the others I must be given one side or one angle, then I can be able to get that angle or the side. Okay, when you do activities, you see what I'm talking about. The cos rule is used when we have SAS. So in other words, I must have a side, I must have an included angle and another side. So it can be like this. So if this angle is given, these two sides must also be given. See? So B, A, C. So this angle is given, these two sides must also be given. Can you see? It's a side, angle, side. The angle is included. So that's when you can use the cosine rule to get maybe this side. Okay, so if that side is not given, I can be able to get it by using the cosine rule. In activities, you see what I'm talking about. The variation of the cos rule is utilized when you are given 3 known sides. So in other words, if I'm given 3 sides, this side, and that side, I can get any of the angle. Okay, so that's what they're talking about in this statement. The area rule operates on the SAS principle only. So in other words, the area rule will also operate like the cos rule. So the 2 sides must be given and the angle must be given. You can see the 2 sides are given and the angle must also be included in there. Okay. Very important, you must read each question carefully to see the link in the sub-questions that follows on. So in other words, you must always read the question and understand the question. And if there are values that you need to put on the sketch, please do so. Okay. Because in most cases you find that it is a it's a long paragraph. You have to read through all those things and make sense of what they're talking about. If there are lines that are parallel, please put them together. If there's a right angle triangle, please try to use the trig ratios. You can see that there's a link, there's a line that links to the other triangle. Make sure that we call it a bridge. So there's a bridge in the lines, then you find that you need to go to another triangle using this bridge. You must first get the length of that line or the angle in between the 2 lines there. Okay, when you do activities, then you explain what that bridge is. Okay. In most cases, you find that in the questions they lead you to the other triangle. So please make sure that you understand it. Now let's look at the sine rule. In the sine rule, this activity, remember what we said in the sine rule? We must have a couple. We must have a known couple. If I check the sketch on the right hand side there, you can see we've got angle R is 80 degrees. Small letter r is 12. So you see there, we have a couple. We have a couple. All right. So now the Q here, so the P angle is not there, the Q angle is not there, and the other side there, it's not there. Right? Now, we need to calculate, but the side here is given. We need to calculate the size of P. We need to determine the size of P. How am I going to get the size of P? The size of P, so how can I work that one out? The size of P, I'm going to use the sine rule. So I'm going to say, first use the known couple. So the known couple is sine of 80 degrees over 12. Then I have the sine of P, which I don't know, all over what I know there, P is 10. So I'm going to get sine of P equals to, obviously, then I'm going to multiply the 10 multiplied by sine of 80, all divided by 12. So in other words, I've cross multiply and then divided by that 12 there. So the sine of P is going to be 0.82, if I use my calculator correctly, and then the P angle is going to be shift sine, and then from there we're going to get that angle, that side of sine of P, the angle which is going to be 55.1 degrees. Right, so I'm going to get that angle. Okay, so this angle now I know is 55.1 degrees. Now the length of PR, which is small letter q, how am I going to get it? First of all, I must get the angle Q. Can you see now? I've got 1, 2 angles in a triangle. The third one I can get it by using sum of angles in a triangle, which means that the angle that I'm going to get there will be 44.9 if I subtract the two angles from 180. So if I've got this angle here and I don't have that side, it's easy to get. So I'm going to say Q, for length of PR, I'm going to say Q over sine Q. But I know what sine Q is, 44,9. It's equals to I must then use the one that I know. I can use the one that I know because the 80 and the 12 I know. So I'm going to say this is going to be 12 over sine 80. Then I can make Q the subject of the formula and cross multiply this 2. Then I'm going to have 12 multiplied by sine 44,9. Then divide by sine 80. And I think that one will be 8,6 centimeters. So the length of that side here will be 8,6 centimeters. Now, here's another skill that we must learn. This angle here is the biggest angle in this triangle. This side here is the longest line. Let's check 49. Which angle is the smallest? It's 44.9. 44.9 is opposite this line here. And you can see 8.6 is the shortest distance from P to Q. In all the three distances here, that one is 10, that one is 12, this one is the smallest one. 8.6, and it's opposite the smallest angle. The biggest angle is opposite the longest line. So this one, it's opposite the shortest line. Okay, so when you're working out these questions, you must also be able to pick this up to say, okay, I think I'm right. If I got here my answer, if it was 15, something, and that angle is that small at 44.9, then you know there's something wrong that I've done. Okay, that's just one skill that you must learn. All right. The cosine rule, how did we say this one works? It works when we have the V. The line here must be given, the angle must be given, this line must be given. Then we can use the cosine rule. Now, what is the length of DF? Now I need to get the length of DF. If I check DF, it's a small letter E. So which means I must also use this one and that angle. All right? So I'm going to say E squared equals to D squared plus F squared minus minus 2 times D times F cos of E. Right. Okay, that's how I'm going to do it. And there's a rule, and that rule is there in the formula sheet. So please must learn that rule. So I can just quickly substitute. The D it's 9. The F it's 7. Minus 2 times 9 times 7. And the cos of 55 degrees. Right. Remember, this is E squared. So E squared, it's going to give us, if I use my calculator, that will be 57, I think it's 57,72. Right? Therefore, my E is going to be the square root of 57.72, which is now going to give me 7,59. That is the distance of that, so it's 7,59. Right. Now, if I need the size of F, can you see F here? I only have that angle, I don't have that angle. The F here. I can either use the sine rule or I can use the cosine rule. But in this case, I'm going to use the cosine rule. Just to show you how we can use the cosine rule when we have all the three sides. So I can use the sine rule. I can say sine of this over that equals to sine of this, sine of that over this. Then I can get that angle. But I want to use the cosine rule. You can use the sine rule also to find it. I'm going to use the sine rule, now the cosine rule. Now in the cosine rule, if I take this rule here, but using f as my subject of the formula, I'm going to get f squared, it's equals to e squared. Remember now I need the angle f. So plus d squared minus 2 times d times e cos of f. But remember now I need that f as a subject of the formula. So for me to get that, so you know how to do the subject of the formula, you must know this must go that side, or we can take the whole thing here to the left hand side, then from there we can work it out. So we can have cos of f, it's equals to, so if I take everything that side, it's going to be d squared plus e squared minus f squared all over 2 times d times e, right? Then I can quickly substitute this, right? So I can have cos f, it's equals to 9 squared plus 7,59 squared minus 7 squared all over 2 times 9 times 7,59. So the d squared is 9, the e squared, I got it there from that question here. Then I have my f, which is 7 squared, then I can do that. So then I can be able to get the cos of f, which is going to be 0,65589, right? Then the f, which is an angle now, it's going to be equals to 49 degrees. Okay, so I can be able to get that in. So the angle, that angle is 49 degrees. And this is what we call solving triangles. So obviously, just as a bonus, I can be able to get that angle here. Right? So if I get that angle there, they did not ask me anything about that angle, but you can still get that angle there, which is going to be 180 degrees minus 55 minus 49, and then the angle that is going to give us there, it's going to be, I think there will be 76 if I'm not mistaken, so that will be 76 degrees. All right, but they did not ask that question, just a bonus. So in this case, that whole triangle has been solved. Can you see? I've got all the angles, I've got all the sides, so I've solved the triangle. Okay. So if they say solve this triangle, then it means that you must get all the sides and all the angles. You must know that. Now the area rule, as I said, this will, the question will determine the area of this. Or if the area is given, determine the side. That's when you use the area rule. So the area of this will be half of B. Remember the angle that is given is A. So it's half BC sine A. So all the letters must be there, A, B, and C. The two letters must be sides, the one letter must be an angle. Then this will be half of, the B side is 9.34. The C side is 5. Then we have the sine of 50 degrees. Then you just use your calculator. I think the area there that I got was 17.89. Remember the area, the unit for area is square. So there will be 17.89 square centimeters. Then that will be the area of that whole triangle. Otherwise, that part here, that whole area, is going to be 17.89 square centimeters. Remember in this one, if I'm given a right angle triangle, that's quite easy. Therefore, I'll use half base times height. But with this one, I cannot use the half base times height because that angle here is not 90 degrees. Okay. If that angle is 90 degrees, therefore I can be able to use half base times height. So in other words, in this case, the base of the angle there, it's included in that formula. So you must use that formula if the triangle is not a right angled triangle. Okay, now exam type questions, which are quite very easy. As I told you, that this type of questions, that's where you get a paragraph. So you must read through the paragraph and make sense out of that. Now it says a flagpole AB. So here's a flagpole here. AB is mounted on the top of a tower. So here is the tower there. So it's mounted on top of the tower. A spotlight S. There's a spotlight S there, which is casts a shadow of the tower OX. So the OX here, the shadow of the tower, and then from which is 12 meters. OX, which is 12 meters. So the 12 meters is given. Already I know that that line there is 12 meters, right? So, and a shadow of the tower and the flagpole together there, it will give us 20 meters in length. So that is given also. That so the whole length here from here to there is 20 meters. The angles of elevation, it's of the spotlight there is 23 degrees and 20 respectively. So of that one and that one, the angles are given. Calculate BO. So you see, we need the length of BO. And you see that that's 90 degrees. And that is a right angle triangle. And I've got an angle 23. And I've got a side 23 there. I mean 12. So it's easier. BO, I can calculate BO. How am I going to get BO? Which ratio will I use? Tangent. Oh, today is the day of tangents. So we're going to use tangent of 23 degrees. It's equals to opposite BO all over adjacent, which is 12 meter. So BO cross multiply BO will be 12 times tangent of 23 degrees. Then BO will give us 5.09. That is the length of that line. So it's 5.09. Okay. All right. Now, B states that calculate AB, the height of the flagpole. Calculate AB, the height of the flagpole. So in other words, you can see that AB is not on this triangle here. So it is on the bigger triangle. Right? But AB here, how am I going to calculate the AB? First, what should I do? I must calculate AO, because I've got 20 here and I've got 20 degrees there. So I can go and calculate the whole length there. So I can say tan of 20 degrees, it's equals to AO, the length of AO. I already know that this is 5.09, right? AO all over 20. So for me to calculate AO, then I'll say 20 multiplied by tan of 20. Then the answer that I'm going to get there will be 7.28. So it means that the length of that whole thing there is 7.28. But what am I looking for? I'm only looking for AB. So if I'm looking for AB, how am I going to get AB? It's going to be 7.28 minus the 5.09. Then the answer that I'm going to get is a simple 2.18 meters. So the height of the flagpole is that one, which is 2.18 meters. Okay. All right, we're going to take a 2 minutes break and we'll be back. Okay, welcome back. The next activity, which is activity 7, also we have a story there, so you must always read that story. The main cable configuration and arrangement of parts. Remember, configuration is an arrangement of parts or elements in a particular form of a mobile crane. So in other words, we have got a crane here. Of that mobile crane is shown in the diagram below. So if they have got a picture of that crane, they will also draw a sketch of that. So just to help you. Now, AE is given, so you must go to the sketch. Sometimes you find that the things that are on the sketch are not the same as that, so you must always be on the lookout. AE is given as 7,5 meters. AD is given as 9,6. BC is given as 2,3. ADB, it's an angle here, is given as 61 degrees. And then BCD is given as 78. So everything is there. So I can be able to see that, oh no, I'm sorted, everything is there. Now, the first question says determine the size of ADE. Must go to the sketch and check. ADE, so it's ADE, so it's that angle that I'm looking for here. Right. First of all, I must check what is given. In which triangle is ADE? So it's in triangle ADE, that long triangle there. So what is given in that triangle? It's the side and the side. And the angle is here. And the 90 degrees is given. So if 90 degrees is given, just know trigonometric ratios, tan, sine, and cos. So in this case, ADE, this side here is opposite that angle, so it's fine. This side here is the hypotenuse. So which one uses opposite and hypotenuse? It's sine. So I'm going to say sine of this angle ADE, it's equal to the opposite all over the hypotenuse. Then from there I'm going to get ADE, that angle ADE, shift sine 7,5 over 9.6. The answer there will be 51.38 degrees. All right, done. Simple, straightforward question. You see what I did? I've used this triangle. I'm not using the whole picture, the whole diagram. I'm only using that triangle to get to this angle. So I know that that angle now is 51.38. Okay. Same diagram, but now we know this angle here is 51.38. Right? Now we need to find the size of BDC. So BDC, so I need this angle here. That's an easy angle. So because I know that the angles at the point will give me angles, adjacent angles will give me 180 degrees. That's an easier question. So I can say BDC will be equal to 180 degrees minus 51.38 degrees minus the 61 degrees. So therefore the angle that I'm going to get is 67.62, I think, 62 degrees. Right, done. So you'll see what this question is leading us to. This one we said is 67.62, right? So now I have all these angles now. I have this one is 51.38. This one is 67.62. Right, so I have that. Now the next question says determine the length of BD. So where's BD? There's BD. Can you see that BD there? Right? Now BD is it's opposite to state. Now I'm using this triangle here. Can you see? BD, it's opposite 78 degrees. So it's a couple, right? But one side is not given. This angle here is opposite 2,3, which is a known couple. So if I've got the known couple, once you have a known couple, it's easier now to use the sine rule. So I can go and use the sine rule there. I can then say the sine of, because I need BD, okay, I need BD now. I'm going to say BD over the sine of 78 degrees. It's equals to 2.3 over the sine of 67,62. Right? Now I can make BD the subject of the formula, which gives me 2,3 multiplied by the sine of 78 degrees, all divided by the sine of 67.62 degrees. It is very important for you, boys and girls, to understand this, making the subject of the formula, okay? So now BD will be equals to 2,43 meters. That is the length of BD. If I multiply 2,3 and sine 78, then divide by that. So that line will be 2,43. It will just be slightly more than that. Right, so now I'll have that angle, so that side, which is BD, which is 2,43. Then what else do I need now? Now I'm going to, the next one, AB. AB, this side here. How am I going to get that side there? So remember, I've got this side here, which is going to be BD, we got it as 2,43. Right, we need that side here now. Right. Now, do we have any known couple? No, but what do I have? This side, the angle, and that side. So obviously, what do I have? I have a cosine rule that can be applied when I've got this side and that side and angle in between. SAS. So I can now say AB squared will be equals to 9,6 squared plus 2,3 squared minus 2 times 9,6 times 2,3. Is it 2,43? Sorry. 2,43 squared. Then the cos of A, or cos of D in this case. Right? Now, because the D is opposite the AB that I'm looking for. So now I can use my calculator, and the cos of D there will be 61 degrees. Right? Because I've already substituted everything. I use my calculator there, so it's 75,5799. Now, therefore, AB will be the square root of that, which is going to be 8,69. Right. So this is in meters. Please don't forget to put units there. So that is in meters. So the length of AB is 8,69. So I can see now that my diagram is, the answer is next to the correct one that I'm looking for. 9.6. That line is very long. 8.69, it's closer to that. So I cannot get, if I get 3 point something here, I know there's something wrong here. So can you see how you can, when you're practicing, you can see. But here, I think I've done this thing, it's not correct. It's not close to what I'm looking for. All right. Now, in the next activity, this one looks, well, very complicated, but it's quite very easy. Now, in this one, it says the diagram shows a vertical rectangle ABCD. So you can see ABCD is a rectangle. BE, F, and C are on the same horizontal plane. So B, E, F, C, they are on the same horizontal plane. Now AB is perpendicular to that, so those lines are perpendicular, and then the angle 60 is given, the 30 is given, the side of that is given as 8, and then we've got this one as 9, and that angle is given as theta, and that one is x. But as we say that it must be given as numerical, you'll see in the next question what they're asking you. Now A the length of AB. How am I going to get the length of AB? The length of AB. Already I know that the length of AB here is the same as the length of CD, opposite side of a rectangle, stating a reason. So AB, it's still going to be 8 centimeters. Opposite sides of a rectangle are equal. Okay, right. So that question is done. So I know that AB, it's 8 centimeters. Now they say determine the length of BE. BE. The length of BE. Now I can, if you check this triangle here, ABE, that triangle here, it's a right angle triangle. Remember that said it's on the same horizontal. So that triangle ABE is a right angle triangle. So if it's a right angle triangle and it's indicated there on the sketch, so which means that for BE I'm going to use the tan of 60 degrees, because tan is opposite over adjacent. I'm looking for BE, so it will be 8 centimeters over BE. So if I make BE the subject of the formula, I'll get 8 over tan 60. BE will now be equals to 5 centimeters. They said nearest to the nearest integer. The answer is 4,6. At nearest integer, it will give us 5. Okay. C says determine the size of EBC. I already know that this one is 5, this one is 8 centimeters. Now they want us to look for angle EBC. It's an angle here, EBC. Right. EBC. So I'm looking for this small angle here, angle EBC. I'm highlighting that triangle here because I'm going to work in that triangle. How am I going to get angle EBC? Now I've got a known couple here. You can see the known couple is this 30 degrees and 5 centimeters. Right? Here is the angle that I'm looking for. This side is 9, so I'm sorted. Sine rule, easy. Known couple, sine rule. So I'm going to go for the sine of 30 degrees all over 5. It equals to the sine of EBC over 9. So I think I'm sorted with that. So I'm going to have sine of EBC, it's equals to 9 multiplied by sine of 30 degrees all over 5. Then I can just use my calculator. Sine of EBC will be equals to 0,9. Then EBC as an angle, shift sine 0,9, then I'll get that angle at 64 degrees. All right. So this angle here now it's 64 degrees. In this triangle now, I can be able to get this angle here. Because if this is 64, this is 30, I think I can get that angle. And that one is 60, I can get it. Okay, but that question is not asked. So let's move to the next one. Determine the area of triangle BCE. So BCE is that whole triangle. Now we want the area. We want the area. But we know this is 8, this is 5. My problem now is I don't have this side here. I don't have that side. But I don't think I'm prepared to get that side. In this triangle, if I've got the 5 and the 9, I just need this angle here. But I don't know what that angle is. This one. But I can get it. How am I going to get it? Sum of angles in a triangle, in this triangle. I already know this one, which is 64. So I can be able to get the angle. So I can be able to get angle AEC. So I can get AEC. So how am I going to get angle AEC? So I'm going to say angle AEC. I need this angle. So I'm going to say it's going to be 180 degrees minus 64 minus 13 minus 60, and that angle will give me 26 degrees. Right. Now I know this angle is 26 degrees. Okay. So if I know that that angle is 26 degrees, that whole angle here will be 60 plus that, which is going to be 86 degrees. So I need this side. Remember, I need BC. Right? I need the area, by the way. I need the area of the triangle. So how am I going to get the area? The area will be half of, I've got this side here, which is 5. I've got that side there, which is 9. Sine of that whole angle now. I know it's 60 plus 26 is 86 degrees. Then I can calculate the area. So the area of that will be 22,45. I think it's meters, or centimeters squared. Right. So that's it. That one was a bit tricky question, because then you needed to find this whole that small angle for the whole side. All right. Okay. So to get that area of that, I needed to get the side I have. This side I have, I need the whole angle, and that was the only trick in that question. Right, so the area of that will be this. Now they say calculate the length of CF. I go to my diagram. So in my diagram, I already have a 5, I already have an 8. I already have this angle here is 26 degrees. Right? Okay, so now I think I'm sorted with that angle. So what do I need here? I need to find the length of CF. Now I'm given that theta here is 25 degrees. The x here is 10. Okay. Now, for me to get CF, can you see that line, small line CF there? What do I have? What do I have for me to get it? What do I have? I have this side here. I have this side there. I have this angle here. So if I've got this side and that side, an angle in between, for me to get that, I use the cos rule, because I've got SAS. So I'll use the cos rule. So I'm going to get CF squared. It's equals to this side squared plus 10 squared minus 2 times 9 times 10. The cos of the angle should be 25. Okay, that's all. So you must just look at this diagram that you're working in, then look at the diagram with more information. For CF, I can't use this triangle. Why? It is because it only has this angle and that angle and that line. That's all. And 90 degrees won't help me much there, unless if I've got the other sides. See? So in this case, what do I have? I'll have 17,86, and then CF will be 4,23 centimeters. There. So I can still get DF. If I've got that one is 4,323, I can still get DF now. I can get DF, theorem of Pythagoras or whatever, if I'm asked to do that, but I must stop there. I'm asked only to get CF. So the 2D, 3D, one thing that you must understand and know in this type of question is to read the questions, read the story, make sure that all the information that is in that story are there on the diagram. The information is on the diagram. It's quite easy. Then you must check which diagrams, which which triangles you are working with. We are working in triangles here. The sine, cos, tangent will only work in a triangle. Okay, so you can see every time when I was using this, I was using a triangle. I was using triangles, so I was using only triangles. I cannot work with sine in a rectangle, you know. So I cannot say the sine of this angle in a rectangle. So it must be in a triangle. As I said, what is trigonometry? It's the relationship between the angles and sides in a triangle. All right. I'm stressing that because you see. Now the coordinates there, at 0 it's 0, at 90 it's 1, at 180 it's 0, at 270 it's -1, at 360 it's 0. Then from there you draw, you don't use a ruler. With a free hand, we draw, we join these points and we join these points, and we give this graph a name, and that name is F. That is a sine graph. So you can put all these values in there, all of them there, just to make sure that your graph is accurate. Okay, now let's look at the domain. So what does the domain, what does that word domain mean in trig graphs? It means, where does the graph start? Where does it end? In this case, the domain of the graph is that. So it's going to be 0 degrees less equals to theta less equals to 360 degrees. That is the domain of the graph. Okay. What is the range of the graph? The range is how high the graph goes. So the graph, how high it's 1, how low it's -1. So the range, the graph will start from -1. I mean, the lowest point will be -1, and the highest point there is a y value. The range, you can put it as an x or a theta. So the range, the range there will be between 1 and -1. Now there's a difference between the range and the amplitude. Now with the amplitude, it is that the distance there and the distance, the equal distance there. So remember, it's the top minus the bottom divided by 2. So if I take the top will be 1 minus the negative 1, so it will be 1 minus 1, which is 2. 2 divided by 2 is 1, so our amplitude will be 1. So you must check the difference between the amplitude and the range. I've put these two together so that then we don't confuse the two. With a cost graph, I'm going to do the same. Cos of 0 calculator, it will give you a 1. Cos 90, it will give you a 0. Cos 180, it will give you a negative 1. Cos 270 will give us a 0. And cos 360 will give us a 1. Now if we check, we have a 1 here, we have a 0, we have a negative 1, we have a 0, and we have got a 1. Right? So then again we use freehand to draw these graphs, and then we have the graph of G in this case. So we have the graph of G. Then you can see this start from 1, stop at -1. So the same principle applies. The range is from 0 to 360. So the theta will be between 360 degrees to 0 degrees. The range will be -1, less or equals to y, less or equals to 1. And the amplitude will also be 1. So those graphs there, remember. So remember how to draw this type of graphs. These are the original graphs that we draw. Okay, so you can see that the amplitude is 1. It's from 1 to -1. So the distance between the horizontal and the highest point on the Okay, so with the cost graph, so you can see it's from 1 to -1. So the highest point is 1 and the lowest point is -1. So that is your cost graph. All right, now the tangent here is the same principle here. So what we're going to do with the tangent, I'm going to go to the 0, 1, so it's 0 there. At 90 degrees, this graph, if you go to your calculator and put tan 90, it gives you a math error, which is undefined. At 180 degrees, this graph here will be at 0. At 270 degrees, this graph here will be undefined. Then we have this graph again at 360, which is going to be at 0. Now, the first thing that you need to do when you draw the tan graph is to look at the undefined points there. So this graph here at 90 is undefined, it doesn't touch the 90. At 270 is also undefined, so it doesn't touch that. So what you need to do first is to draw those boundaries in there. Is to draw those boundaries there, so that then you know that those graphs do not touch there. Now, the tan graph works much easier with the 45 degrees. So in other words, we must get at least, when you do your table there, I know that those who know how to use a calculator to do it on the table, when you go to step on your calculator, you must put 45 to draw the tan graph. So if you draw your sine and your cos graph, you can put step 90 there. So with the 45, you know, tan 45 will be somewhere there, it will be 1 there. At 135, which is somewhere there, it will be -1 there. I'm just putting this point so that I'm able to draw this graph. Right, at 225, which is somewhere there, it's going to be 1. Right, so now at 315, which is somewhere there, it's going to be -1. Right, so I'm just putting this point so that I'm able to draw this graph, but you can use a calculator to get all these other points. So for you to be at least a bit accurate, you can use this value, so you can use the 45 interval. So then from 0, then I draw this graph, I move, and this graph must go closer and closer to this line, but it must not touch. These lines here are called asymptotes of the graph. Right? So this graph will not touch those two lines. So from here, this graph will go up, 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 up. And then from there, you must put arrows there because that graph is still continuing. Then here, because it stops up there and it doesn't touch that line, obviously it's going to start down there, and then from there it joins and it stops here. Please, it does not continue. It stops there. So that graph will stop there and it starts there. No arrows there at the end and no arrows at the start. Now, what is the domain of this graph? So this graph will start, so there's an issue also of the period of the graph and the domain. So with the period of this graph is 180 degrees. So in other words, I'm just going to include that here. The period of this graph is 180 degrees. But if I look at the domain, this graph starts here and ends here at 360 degrees. That is the domain of the graph. So the domain of the graph will be starting there. This is the domain, it is not the period. So it starts from 0, it's finishing at that. But we know in this case here, x cannot be 90 and x cannot be 270. So that must be also be included there. So x cannot be 90, or theta cannot be 90, and theta cannot be 270 degrees. Can be any other value. In this case, from 0 to 360 in that case. What is the range of this graph? In other words, how high does this graph go and how low does it go? So the range of the graph will be -infinity. So I'm going to write this y, it's an element of -infinity to, remember infinity, we don't include it, ne? To +infinity. Right. So this graph, there, you see, it's got all these other values. All these other values there. But the graph there is from -infinity to +infinity. What is the amplitude of that graph? That graph does not have an amplitude. Right. Right, that graph does not have an amplitude. The tan graph does not have an amplitude, but it has a range, which is -infinity to +infinity. Okay. Now, the next activity there, we're given the two functions. H of x is cos x. P of x is sin x plus 60. Can you see that angle there? It's not a value. It's not x plus 3. If it's x plus 3, it means that the 3 must be outside the bracket. So here we're adding angles from 0 to 360 degrees. Now, the first question says, what is the period of h? Remember, the period of sine graph and the period of the cos graph are the same. So the period of that cos graph here is going to be 360 degrees. We see a lot of learners writing x is an element of 0 to 360. You cannot write an interval for a period. So the period, it's a number, it's that number, 360 degrees. So now how do I get the period? Remember this value there, it's 1. So if it's 1, so I'll say 360 degrees divided by 1, and that is the period. If that number was 2, I'll say 360 divided by 2, then the period will be 180. If that number was 4, it will be 360 divided by 4, which is 90. The period will be 90. So that's how we get the period. But because it's 1 here, so it's 360 divided by 1. What is the amplitude of P? So remember, that is your amplitude. How high will that graph go, and how low will that graph go? Is the top minus the bottom divided by 2. So when you draw the graph, you must also learn that. So in this case, the period of that graph there will be 1. Right. Okay, so now in the next question it says draw the sketches of P, N, H, and P. So remember, the graph of H is the normal cos graph, because we're having the cos graph here, cos x, which is H, and we've got the graph of P, which is, remember, it's H of x and P of x. So the P of x is the sine of x plus 60. Right. So you use a calculator to do that. You input in a calculator, you go to the table, you input the first graph cos x, the next graph you put sine of x plus 60 degrees. Then you get your points. So the cos graph is quite easy. It started at 1, 90, 180, 270, 360 is 1. Right. So the cos graph is quite easy. You draw the cos graph like that. You name the graph, it's H. Alright. Now the sine x plus 60, you can, if you don't know how to use the table, you can just input the values. If I put sine of 0 plus 60, so it will be sine of 60. So sine of 60 will be somewhere there at 0,8. Then at 90, you take it to 120. I think at 120 it will be there. It will be at 180. And then these values, obviously you still need to go up with that graph. 30 plus 60 is 90. So at 30 it will be at 1. Then from there you have the input. You have an input there at 120. So what you're doing, you're just adding a 60 in with this angle. So at 210 it will be at 270, which is going to be -1. So I can do that. Let me just do the points here. This points, that points, and that point. So it goes up there, and then from there at 300 it will be at 360. It will be at 0. And then from there it will go to that point here. So I'm going to draw that graph here. So it goes like that, and goes there, and goes there, and goes there. Right. So I can just shade it a bit to make it different to the other one. Then I have that graph. Okay. Right. So those are the two graphs. You can see with this graph there, it's going up to 1. So it goes to 1 there. So therefore, and it goes there up to -1. Which means that the period of that graph there, the amplitude of that graph will also be 1. Right. In that one, on the same set of axes, here you are having the graph of 2 cos x. Remember, with 2 cos x, the amplitude now of that graph is 2. So the top part is 2, the bottom part is -2, but the amplitude is 2. Even if they write a -2 there, the amplitude can never be a negative number. It must always be a positive value, which is a 2. This graph is starting from 0 to 360 degrees. Okay. Now they say we must draw the graph of x minus 30. I think that graph will start somewhere at negative 0,5. And then from there at 90, it will be 90 minus that, so it will be at 0,866. Then at 210, it will be at 180. So it will be at 0. And then from there 270, it will be at 300. I mean, sorry, 270, it will be at 240. If I put a 360 there, I mean 360, it will be at 330. So you're just adding the values there. So this graph will go up here, then from there it will go down there, and that graph, the end point of that graph will be somewhere there. So it will be somewhere there at 0,5. Right? And now we know this graph, it's f, and that graph there will be g. Okay, so you must use your calculator to draw these two graphs. You must input the values in the x, subtract and get the value. Put input, subtract and get the value. The easier way is to go to the graph, is to go to your calculator and input these two graphs. Then from there you get the values. Okay, right. Now with the two graphs, they say now write down the range of g. So remember the g graph was that one that starts there and goes there, and I know it goes somewhere there, and then from there it goes somewhere there. Now they wanted the range of g. So what is the range of g? Remember the range is the y value. So the y value of that graph. The range of this graph here, this is the g graph. So the range of that graph is how high the graph goes and how low the graph goes. Okay, of g. So the graph, the minimum, maximum, and then from there the minimum and the maximum. So you can see that graph, it can go up to 1 and it can go to -1. So the range there will be an element of. Remember, that is not the minimum of the graph. The minimum of the graph is there, and the other one is supposed to be there at 1. Okay, so now the minimum of the graph, so it's -1, then from there it must be to 1. So it's the same as -1 less or equals to y less or equals to 1. Okay, what is the amplitude of that graph? The amplitude of that graph will be 1. As simple as that. Okay. Oh, sorry. The amplitude of the cos graph. The amplitude of the cos graph will be 2. Remember, it was y equals to 2 cos x. So the amplitude of that graph will be 2. What are the values of x? For which values of x is f of x minus g of x? It's equals to this, 2,5. So in other words, that graph here is at 2. So if I take the top graph, the year, remember, it's at 0,5. So if I take the top part and subtract that top part, that bottom part here, let's look at this. What will be the value? Where will that value, the two graphs subtracted together, give us 2.5. So if I take the top, it will be 2 minus into 0,5, and this will be 2 minus into negative that, so it will be 2 plus 0,5, and that will give us 2,5. So if I take the f graph will be at 2, the g graph will be at negative 0,5. The answer that I get will be 2,5. At which point will that one be? At which degrees? It will be at 0 degrees. Again, where will it be? I think somewhere there at 180 degrees. It's supposed to be there at 0,5. It's also going to give us, because that will be -2. So it will be the top minus the bottom, which is also going to give us 2,5. So it will be at 180 degrees. Where again will that give us a 2,5? This graph is at 2. At that point it's at 0,5 negative. If I say 2 minus, remember it's the top graph minus the bottom graph. So again, it will be again at 360 degrees. So at these three angles, that's where the graph, when we subtract the two graphs, we are going to get 2,5. That is what the question is asking. Okay, so the two graphs drawn together, when we subtract them, we use the top. F of x is the top part, g of x is the bottom part there. Then we have those two subtracted, give us that. So for which values of x? So the x values that we're talking about are these ones here. Right, so we just check where the graph, when I subtract the top minus the bottom, where do I get 2,5? And this is where I get 2,5, those 3 degrees. All right, let's preview the next lesson. The next lesson will be on the 7th of May 2025 at 14:30 to 16 hours. The topic that will be done will be revising the grade 11 Euclidean geometry. Let me take this opportunity to thank you for watching, and please let's practice this mathematics, technical mathematics. It can be done. Thank you.